Alright, I need to introduce you now to parametric equations. You've been dealing with equations for years that look like, y equals, let's try this again, y equals f of x. This is not parametric. This is what you're used to. You have an independent variable x, you plug it in, you calculate what y is, right? And you look at graphs that do whatever. For each value of x, there's a y value that you calculate, and that's what the graph looks like. Now I want to look at parametric. Parametric takes both x and y and treats them as dependent variables, where you have some other independent variable. So x is going to be some function of t, let's say, and y is some other function of t, let's call it g of t. And the variable isn't always t, but it quite often is t. T is what's called the parameter. Parameter, there we go. So for each value of t, you're going to figure out what x is, and you're going to figure out what y is, and then we'll plot those points. Okay, let's look at some examples here. Here's my first example. I want x equals 2t and y equals 1 minus t squared. Now, in order to plot the graph of this thing, I want to show you several different ways. We'll start with probably the basic way that everybody learns how to plot graphs. In fact, back up here when you first learned how to graph y as some function of x, you probably just picked a bunch of x values, you made a table, right? You calculated the y values, and then you just plotted all the points and connect the dots, right? Well, I guess I'm going to start that way. We want to maybe build later to some other techniques of not having to plot points every time. But let's see. My table is going to be a little bigger now because I have to have t, and then I'll calculate both x and y. So I'll leave myself a little room here. So let's see. Let's pick some values of t and then see what happens. Now, really, I should take all the values of t from minus infinity to plus infinity, but that's kind of a lot. So I'll just do a few of them and then see if I can figure out what's happening. So I'm going to try plugging in t equals -2, -1, 0, 1, and 2. I'll start with that, and then we'll see if we need to do any more. So this is the way we go it. I'm going to calculate an x value using the equation that relates x and t. So x is equal to 2 times t. So this should be 2 times -2, which is -4. The y value then I'll calculate as 1 minus -2 squared. And that's 1 minus 4. So this is -3. Okay. So the first point that I've got here is -4, -3. So I'm going to draw a graph over here. And -1, 2, 3, 4, -1, 2, 3. So that's my first point corresponding to t equals -2. Okay, that's that point right there. This is an x and a y axis. I should point out here that I'm plotting x and y. T is kind of lost. The fact that that's t equals -2, I had to point that out. You wouldn't be able to see it from the graph. You'd just be able to see the x coordinate is -4, the y coordinate is -3. Okay. So then I'm going to plug the t equals -1 in, see what I get. Well, 2 times -1 is -2. 1 minus -1 squared is 1 minus 1, which is 0. So I'm at the x coordinate is -2, the y coordinate is 0. So 1, 2 right here. Okay. That's t equals -1. Right. Next point, plug the 0 in. 2 times 0, that's 0. 1 minus 0 squared, well, that's 1. So I have the point 0, 1. So I'm right here now. That's it. T equals 0 at this point. And next, what are we doing? Plug a 1 in. 2 times 1 is 2. And plug it in to get the y value. 1 minus 1 squared, well, that would be 0. So now I'm at 1, 2, 0. There we go. t equals 1. And for the moment here, the last one I'm going to do is 2. 2 times 2 is 4. 1 minus 2 squared is 1 minus 4, which is negative 3. So I'm at 4, negative 3. Right? Now, there's a lot of other points I could have plotted. So essentially what I need to do is just interpolate and say, well, I'm going to connect the dots here. So I assume if I'd picked a value of t between negative 2 and negative 1, I'd be getting a point somewhere in between here. And I end up drawing this curve. It looks like it's probably doing something like that. Okay, you can plot some more points if you want to see a little more accurately, but it looks something like that. Now, one thing I want to point out is that this looks like, I don't know, maybe a parabola. It turns out it is a parabola, but I don't see this as just a parabola. I see this as motion along a parabola. If I think of t as time, then these formulas are telling me where I am at any time. The first one tells me the x-coordinate, and the second one tells me the y-coordinate of my location at any time. So at time negative 2, I'm right here. And then time passes and I move along the curve, and at time negative 1, I'm here, and then it continues to pass, and I'm here at time 0, there at time 1. This was time t equals 2, right? So to me, this is more than just describing this curve. You're describing this curve with motion along that curve. Okay? And that is one of the powers of parametric equations. Oh my, you do not yet know the power of parametric equations. Yes, I use parametric equations all the time for lots of things, as you'll see. So let's do another example here. Let's try something like this now. How about x equals negative t and y equals 1 minus t squared over 4. 1 minus t squared over 4. Okay, so we'll make ourselves another table. Again, I'm going to get away from tables eventually, but it's a pretty good way to get started. So x and y. So let's try the same ones. Let's try minus 2, minus 1, 0, 1, and 2, just to get an idea of what this graph might look like. So when I plug in and calculate x, so I'm plugging a negative 2 in for t here. Negative 2 would be 2. And for the y value, it's 1 minus negative 2 squared, so that's 4 over 4. So that's 1 minus 1 is 0. So let's plot my points here. At time negative 2 this time, I'm over at this point right here, right? So different set of parametric equations than I had in the previous example. I wouldn't expect to be in the same place. So here I am at t equals negative 2 right there. Alright, try t equals negative 1. Negative 1. So negative of negative 1 is positive 1. And 1 minus negative 1 squared is 1 over 4. So that's 1 minus a fourth, so I'm at 3/4. Not quite up to 1, maybe. Yeah, 3/4 is about in there somewhere. Well, something like that. Plug a 0 in. Negative 0 is still 0. 1 minus 0 squared over 4. Well, that's going to be 1 minus 0, which is 1. So here I am. So this was t equals 0. This point right here was t equals 1. Plug a 1 in. I've got negative 1 for the x value. And 1 minus 1 over 4. Try that again. 1 minus 1 over 4, which is again 3/4 for the y value. That was t equals 1. And lastly, for now at least, we'll plug in t equals 2. So that's negative 2 for x. I'm looking at that thing. And 1 minus 4 over 4, 2 squared on the top, right? So that's 0. So here I am at negative 2, 0, right? The graph over here doesn't involve t once you've figured out x and y. You just plot x coordinate, y coordinate. That's the point. I'm only putting the t's in there just to show you where you are at any value of t. So this is t equals 2 right there. And, well, I see a bit of a curve like that. Now let's do one more. Let's go to 4. Plug in a t equals 4. X is 4. y is 1 minus 16 over 4. So that's 1 minus 4, which is negative 3. This point right here. You could plot some more points to see what it looks like. It seems to be doing something a lot like what the last one did. It kind of looks like a parabola. Actually, in fact, I'll be able to show that it is exactly the same curve. I'll do that in the next video. But what I want to point out here is the distinction between what just happened. I just gave two examples that gave me two parabolas. Actually, it gave me the same parabola twice. But these are very, very different situations. This first parametrization describes motion along this parabola from left to right. The second parametrization described motion from right to left. That is, as time increased, as the t-value increased, I moved from right to left. Also, if you're thinking in terms of motion, this thing was moving faster. From time t equals negative 2 to t equals positive 2, you got all the way through from this point on over here to that point over there. For the same values of t, negative 2 to positive 2, you only traversed a little bit of the arc here, right? So we have the ability now not only to describe curves, but to describe motion along a curve. And if you think about how many things in this world move, and how many things we might want to describe their motion, airplanes coming into an airport, anything that moves can be described in terms of parametric equations, because you think of time as your parameter, and then you just describe both x and y locations at any time, and you're describing motion. This is what parametric equations are really, really good at. Okay, so in the next video we will do a thing called eliminate the parameter to see that these two examples really are the same parabola.